Alright gang, here's our last lesson from Chapter 1, and it's on graphing linear inequalities. When we see an inequality such as this, and we know we have to graph it in the coordinate plane, that will always involve some shading. Here's a shady character over here to supervise us in our endeavor. Just wrote some steps over here that are really pretty basic. We want to try to graph the line. And we'll talk about this, a solid or dashed line, here in a little bit. And then we do have to shade one side or other of this line. Oftentimes that's called a half plane. So we're going to pick something called a test point, and we'll use that to determine which side we actually do our shading on. Alright, so let's take a look at this graph. X minus 2y is less than 8. I'm going to graph it like this because this is a line that's essentially in standard form. So I'm going to make a little chart here, and it looks like it's going to be a pretty nice one that I can use this intercept method of graphing. So if I put 0 in for x, so x is not there, I have negative 2 times y. I'm going to pretend that this is an equal sign for now. So negative 2 times what equals 8 has to be negative 4. So I know the point 0, negative 4 is on the graph. So I'll put that point there right now. And in like fashion, that's the y-intercept, by the way. Now I'm going to try to find the x-intercept. So I'm going to put 0 in for y. And of course, negative 2 times 0 is 0, so then this has to be 8. So here's another point for us, which is 8, 0. Now I'm going to go ahead and draw that line. And here's though something we need to watch out for. Remember up here we said, should it be solid or dashed? And in this case, it's going to be a dashed line because of this inequality. It's just a strictly less than sign. Whenever your inequalities are strictly less than or strictly greater than, we use a dashed line. That indicates that the line is not a part of the official solution. So here's my dashed line. Now I just have to figure out whether it should be shaded on the top of this line or on the bottom. And here's where that test point comes in handy. Now a test point is some nice ordered pair that will work pretty readily in an inequality that we can quickly decide whether, when we substitute in there, whether it's going to make a true or false inequality. And the most common test point that I would recommend that you use, if possible, is the point 0, 0. Very easy to substitute, easy to figure out whether it's going to be true or not, really just in your head. So notice in this case, 0, 0, if I put 0 in for x, 0 in for y, I'm going to get 0 is less than 8. That's the inequality I end up with, and sure enough, that is a true statement. And so that means the place where 0, 0 is, that's going to be where the shading occurs. And you can do any kind of shading that you want. I usually just like to draw some lines in there like that. So there's the solution to that inequality. Now, you would almost always want to use 0, 0, except if your line that you drew went through that point, went through the origin, then you'd want to choose a different point as your test point. But 0, 0 is a good option for almost all of the cases that we'll look at. You may or may not know that you can also do some shading like this right on your graphing calculator, though I can't often recommend it, but let's just go through the steps how you would do that. This should be the same inequality that we saw in the last slide, but remember, in order to put this in your calculator, you need to solve it for y. And I got 1/2 x minus 4. We'll talk about this more in class. Remember, when we're working with inequalities and you have to end up dividing by some negative numbers, perhaps you need to switch the inequality around. But anyway, here's what the line looks like. I was able to graph it, obviously, like we're used to. Now, here's how the shading works. If once you have your equation, linear equation in your y equals, you can move your cursor way over to the left of all those y's. And once you press enter, you'll see all these different configurations that occur way on the left. what happens here, this is a triangle in the upper right, that would indicate shading up. If you keep hitting enter, there'll be another triangle below that. You keep hitting enter and you can see some animation, an animation with a tail on it, which is useful in some applications. But in this case, I knew that my shading had to be going up like this for that 0, 0 to be considered true. So in a sense, you have to think about that test point before you enter this into your calculator, which makes it a little bit tedious. So your calculator can do some shading, but you do have to put some thought into it to figure out how to display it properly. Alright, and then the last one we're going to look at here is kind of a compound inequality of sorts. This one has, as you can see, an x minus y in the middle of the negative 2 and 8. So really the way we're going to have to deal with this inequality is split it into two parts. First of all, we'll do x minus y is greater than or equal to negative 2. Now, how do I go about graphing that? Well, a couple things we could do. Let's just try solving this for y in this case, so we have some practice doing that. I'm going to get that x on the other side, so the minus sign stays with y. So I have y greater than or equal to negative x minus 2. Now I don't like that negative sign here in front of the y, so what I'm going to do is essentially divide everything by negative 1, or you can think of multiplying everything by negative 1 to make that positive. So I'm going to get a positive y there, a positive x here, and a positive 2 on that other side. But here's what we talked about earlier. When you multiply or divide an inequality by a negative number, we must switch or reverse that signage. So here is my actual inequality. I can graph this. This is just a nice linear form. I see that my y-intercept is 2 and my slope is 1, so basically I'm just going up 1 and over 1 like that. Okay, so there's what my line is going to look like. Now notice in this case I have a less than or equal to sign, so now when I draw my line in here, it's going to be solid, meaning the line is a part of that solution. Now we're not quite done here yet, because what I now have to do is take that x minus y, and now I'm going to do the second part of this inequality. X minus y is less than 8. So in this case, I think this is one where I can solve this for y again. So I'm going to subtract x from each side, so it looks like that. Multiply or divide by negative 1, so I get y, x, and there's my minus 8. Again, my signage has to switch here, doesn't it? Because I did divide by a negative number. So what I have left here is the equation of a line. I see that the y-intercept in this case is negative 8. Once again, a slope of 1. So it's going to look something like this. Now, I'm going to draw or sketch this line, but notice now because it's simply a greater than symbol, now I'm going to use dashed lines when I graph this. You'll be able to do that a little more accurately. Now, should there be any shading here, or is this all I really need? Well, once again, because of those inequalities, there should be some shading. So let's just pick a point. The test point, again, is a good thing to figure out. Let's pick 0, 0 once again and see what happens there. If I put 0 and 0 in for x and y, I'm going to end up with negative 2. Everything kind of cancels out in the middle, and then I have negative 2 with a less than symbol and 8. And is negative 2 less than 8? Yes, it is. So that means my shading should be in the middle of these two lines here, kind of a corridor aspect there. So once in a while you'll run into inequalities like this. We call this a compound inequality. So thanks for listening, gang, and we're almost done now with this chapter, so we'll work on this stuff tomorrow and we'll be getting ready for our test pretty quickly. Bye now.